Literally anything that does graphics computation can get you to where you can play a game. Now I might be holding in my hand an Athlon processor with Radeon Vega graphics. And you might be thinking, is this another video from yet another YouTuber that's like, look, just play the APU, the integrated graphics is totally okay. You can run with that. The answer is no. No, we're going to hack Windows. And we're going to make things happen that are not supposed to happen. We're going to reveal things that are not supposed to be revealed, or at least that you're not supposed to be reminded of. Let's take a look. There's basically 3 different CPUs from AMD that have integrated graphics. This is the lowest end. This is about a $35 processor at Micro Center, $50 MSRP. It's the Athlon 3000G. This is a dual core with Vega graphics and sort of the weakest of weak sauce Vega graphics. It's an AM4 CPU that'll work in a lot of different motherboards, but not every motherboard. You gotta also have BIOS compatibility as well. And because it's so low end, you don't see a lot of BIOS support on higher end motherboards for the lower end APUs. I mean, it's just kind of a fact of life. But I mention it because it's two cores and built-in Vega graphics. Now, I wouldn't ask you to play games on the built-in Vega graphics. We're gonna get to that. Middle of the road is something like the Ryzen 5 3400G. It's 4 cores, has built-in graphics. Higher end, something like the 4750G. We reviewed the 4750G in the ASRock Desk Mini X300 a little while ago. That is a very capable, very powerful machine. It doesn't have any PCI Express expandability in terms of adding another GPU, so you'll have to be happy with whatever the APU, the integrated graphics, can provide for you. You may be looking at an Intel-based system with its iGPU, and the 11th gen iGPU, that's a pretty good upgrade over the 10th gen iGPU, but again, it's still that iGPU territory. It's not quite as good as discrete graphics. Most of the time, when you use hardware in ways that it wasn't intended, there's no software support. And you honestly will have a better experience with something like Linux rather than Windows. But the dirty little secret is the software support for the hackery that we're about to do, it's already built into Windows. It's just for laptops. Like this Surface Book, it's got, built-in graphics, and it's all in the screen. The processor's in the screen, a weak sauce battery's in the screen, memory, literally everything pretty much for this entire computer is in the screen. I can hit a button, I can separate the keyboard from the screen, but there's a GPU in the keyboard. An NVIDIA GPU, a pretty decent one, and more battery, because there was just not enough battery up here. It's anemic, it's not great. So, this link here, it's a PCI Express by 4 link, don't let Microsoft call it anything else, that connects the CPU to the GPU. And a lot of laptops have this kind of setup, usually not PCI Express by 4, but usually there's some kind of a connection to a discrete piece of graphics in a laptop so that you get better performance. As a result of that, Windows really handles that situation well. And the secret is that the built-in GPU, in this case our Intel CPU or our other laptop, that display is hardwired to the output of the built-in graphics of the CPU. It's not hardwired to the GPU. That's not really exactly how they do it. I mean, sometimes it can be a shared bus, and we're getting into the weeds here a little bit. But by and large, the CPU is the thing that's connected to the display. So how do you get information from the graphics card, the discrete graphics card, the add-in NVIDIA graphics card in a laptop? How do you get that, the output of that if it's not physically connected to the display? And the answer is that the memory copy happens over the bus. There's a little bit of a mechanism there in the system that will copy frame by frame as they're rendered from the GPU to the built-in GPU. And in Windows, there's a menu option. You can actually say which GPU is your powerful GPU and which GPU is your weak sauce GPU. Now, NVIDIA almost let the genie out of the bottle with this about a year and a half ago, give or take, because you could actually have multiple discrete GPUs. You could have like 3 GPUs in a system, and Windows 10 would let you sort of pick which one went where. And so you could sort of use GPUs in kind of an off-label kind of a way. You could get a cheap Quadro graphics card, add that to your Windows system, and then all of a sudden your GeForce card is acting like a really expensive Quadro. And that's the secret that companies are very nervous about reminding you, the consumer, or you, the person that's interested in the product, about. And that is, there's really only a small number of spins of the silicon. There's little knobs and tunables that have been turned, but when a graphics card company goes to make a GPU, there's really not a lot of variations of that silicon. Sure, some things might be fused off, some things might be turned off, some things might be moved around, but the really expensive AI GPU usually is not a lot different than the CAD and workstation GPU. It's not a lot different than the gamer GPU. And that's what it's taken me so long to get to. The Tesla K40 here, that is a sub $100 graphics card on eBay, can be used like it's a built-in GPU on a laptop. And it's really not a big deal to set that up. There's a couple registry entries that you have to set, and things like boost clocks don't work exactly the same way. Fortunately, one of our level 1 community members, gigabuster.exe, which is sort of a fun name in and of itself, has figured out how to manipulate the registry so that you can use your Tesla AI, machine learning, data center card as a gaming card. Because at the end of the day, it's the same silicon. Kepler in this particular case, but also the Maxwell variants of this, those are a little more than $100. The Kepler version of this performs about like a 980 Ti, but we've got 12 gigs of VRAM because this was an enterprise grade card. So if you want to do this, there's a full write-up and guide on the Level 1 forum, but basically it's just a little bit of registry changes. You'll also have to use NVIDIA SMI from the command line. The reason for that is the GPU out of the box will only run about 745 megahertz. You want a faster clock than that for better performance. Generally, the enterprise, the data center parts, those run at lower clocks because they're running 24/7 and they need to be 24/7 stable. Gaming GPUs are anything but 24/7 stable. So you'll need to run NVIDIA SMI and find sort of the sweet spot for your card. Well, we've had a couple of more days and a couple of more GPUs to test that came in from eBay. I'm happy to report the Maxwell-based Teslas also work really well. In fact, even better than Kepler because, well, they're newer. So with Maxwell, you don't really have to fool with the NVIDIA SMI. Everything's great there. But it's not all roses. Not every game actually works perfectly correctly. We found that Dirt 5, for example, was a little problematic and buggy when we're doing this. But we also tried it on a laptop. And a laptop with multiple GPUs is also a little problematic and buggy. So that'll probably get fixed in the game, especially if you're trying to play Dirt 5 on a laptop. But most games actually work really well. Also, PhysX. PhysX is kind of important, especially if you're playing like Batman Arkham Knight, especially on a lower end machine. Having that calculation happen on the GPU, I mean, this game is basically built to show off PhysX. Well, you can do the standalone PhysX installer because you got to do, the Tesla drivers from the NVIDIA website, so they don't really include that exactly. But if you do the standalone driver, you can actually pick the Tesla GPU, so you can install those separately, install them first, then you install the other drivers, and hey, you can use the same GPU for both PhysX and the rest of the game, and it works. So this is not a solution without caveats, but if you can get your hands on some cheap Tesla cards, this might be an option during this great GPU drought of the 21st century. The other consideration is cooling. Physically, these cards are designed for servers, which have active cooling. You might remember from the Tesla V100s, which are still thousands of dollars on eBay, that I 3D printed some adapters so that I could use those in a desktop case. Now in a server case, a server chassis, there's no problem. There's baffles, there's little bits of plastic. You guys might remember from the Gigabyte chassis, they have little pieces of plastic to help direct airflow through the GPUs. And those GPUs, even though they're 250 watts, 240 watts, 260 watts, depending on how you get the TDP configured, they don't have a fan. And it's not because they're, super efficient and they're not generating a lot of heat, they're doing a lot of work. That's not how the laws of thermodynamics actually works at all. Yeah, all of it is going to heat. Every bit of it is going to heat. Not even a little bit that's not. It's all going to heat. It's all going to heat. So the situation here is that you need airflow. You need to dissipate that heat through airflow in servers. That's usually a lot of fans at the midplane. Not every device has its own fan. But in a desktop chassis, you're going to need some stuff. So fortunately, there's 3D printable adapters. You can convert a desktop fan or a blower style fan in order to cool this. And if you don't cool it, it's going to overheat and not run correctly. So this is not a solution for the faint of heart. I mean, using a Tesla GPU for gaming, not generally recommended. But this is level 1. This is how we do things around here. At the end of the day, this is basically the same silicon that you find in a gamer GPU. Once upon a time, somebody paid thousands, if not tens of thousands of dollars for this class of GPU. Now it's basically e-waste, and we're going to game on it. And you might be thinking, wait a minute, aren't companies making mining grade cards? I mean, NVIDIA is certainly making mining grade cards. How are they any different than this? And the answer would be they're not. Really not a lot of difference. Practically no difference, in fact. These GPUs don't have a physical output, just like a laptop GPU, and the driver software and all of the plumbing necessary to get the game rendered on one GPU and then transported to the other GPU to display, it's already there in Windows. We don't have to do a thing. I get not supporting it officially, but at least don't make it more difficult than it needs to be, companies, especially during the shortage right now, because, hey, if you can get 980 Ti level performance for about $100, why not? Check out GigaBuster's how-to. This has been a lot of fun to work on. Check out this system. It's really a lot of fun. You got to be careful a little bit though, because I mentioned 12 gigs of VRAM. A lot of these enterprise-grade GPUs that have a lot of VRAM will not boot correctly on older platforms. Now, the platform we're using here, to be sure, it's B350 with the, we did some testing with the 3400G and the Athlon 3000G, but also the 4750G. I mean, 8 cores with a 980 Ti, that's a pretty solid gaming experience. But sometimes when you add these GPUs to older machines, it won't even boot. And the reason for that is because the BIOS architects at the time never figured that there would be 12 gigs of VRAM in one of these older machines. And so there's not really enough PCIe ROM bar space, that kind of thing. If you're gonna set this up, there's also some best practices that you'll need to follow. You'll want to turn on above 4G decoding. You will want to turn off CSM. You want to try to make your system as UEFI compatible as possible so that you've got, sort of the newest platform. That's a little bit more on the Windows side than the hardware side, just to get Windows to do what it's supposed to do. There's some BIOS settings you'll need to change. All that's detailed in the how-to. This is not something that everybody can do with every single piece of hardware. We tried it on older systems like Z77, Z87, and it wasn't pretty. Even X99 was not universally well supported. It might work on one X99 board, but not another X99 board. X299 should be okay. B350, first gen Ryzen, those should be okay. I think older systems like the 8350, probably not okay. Your mileage may vary. So yeah, 12 gigs of VRAM for $100 and reasonable gaming performance. Yeah, not bad. Pretty well done. Thanks, GigaBuster. I'm Wendell. This is Level 1. You can find us in the Level 1 forums. I'll see you there.